Hi, this is Jeff Coronado on behalf of JCSC, and this is a session in Bridging the Gap. So let me tell you, Bridging the Gap is a series of structural engineering design tutorials that we have developed in order to assist young and even aspiring structural engineers into kind of breaking into the field, right? So if you are if you are graduating within the next year or two, or if you recently graduated, let's say within the last couple of years, I think as we all know, structural engineering can be or is very competitive. It's a very competitive field to get into. There are very few positions for the number of civil engineering graduates that there are out there. So this is a series of tutorials intended to bridge the gap for what you learn in school as compared to what industry expects you to know. So, so hopefully by bridging that gap, this will give you a better chance to gain traction in the field, to get into the field and gain traction in the field. So with that said, let's jump into today's tutorial. The question that came in from one of our young structural engineers here is, what is the trigger to determine if I have substantial structural damage to the lateral force resisting system? Okay, and this project was in California, so the code that governs there is the California Existing Building Code, and in particular, we're focusing on the 2019 edition of that code. So if this is a project that's elsewhere in the United States, the provisions in the International Existing Building Code are pretty similar, so you can check that. But at least in flavor and spirit, you should find that what we will cover here will match substantially what the IEBC covers. But here in particular, and by the way, if there are any things that I say that are not clear to you, feel free to leave us a note at the end with any questions or comments. If you found this tutorial to be helpful, certainly appreciate you giving us a thumbs up and even subscribing to our channel. And that way you can, I think there's a flag that you can set once you subscribe to the channel that will then automatically alert you to any new tutorials as we post them, so that you can gain the knowledge of that. But here in particular, if there's anything that I say, by all means, leave me a note at the end, and we'll see if there's other tutorials that we have that we can point you to that will help you in understanding whatever it is, the question that you have. Okay, don't skip around. That's one thing that I always admonish people. Don't skip around. This isn't about trying to pick off, it's not a buffet. You're not trying to pick off a value. You're not trying to pick off one sentence, because if you do that, you're always going to be depending on tutorials, right? What you want to do is learn to think as a structural engineer. The sooner you do that, the sooner that you understand the thinking behind how we arrive at these solutions, then the sooner that you will need to stop or you'll be able to stop listening to tutorials and looking for tutorials, because you will understand how to think as a structural engineer. So with that in mind, okay, I believe I left off at if I say anything that you don't understand, by all means, leave us a note at the end of the session, and we'll try to point you in the right direction or clarify it for you, okay? Oh, I'm sorry. We had gone to don't skip around these tutorials for your own benefit. Okay, so structural damage from what? What can we have structural damage from? Oh my goodness, so many things, right? Wind events, floods, vehicle impacts, fire, right? So many more things that cause harm to our structures. So really, repairing an existing structure can come at us from so many different directions. Am I doing this right? Okay, So when we do have damage as structural engineers, we have to make one of two decisions. We are either going to repair in kind, what we would refer to as in kind, or we're going to repair code compliant. Okay, so what do those mean? Well, in kind basically means that we are going to replace the damaged element with another element just like it. All right, so let's take as an example, timber construction. I think we all know what a 2x4 is, right? So let's assume that there is a 2x4 piece of wood and it's damaged. In kind means that if there was a 2x4 there, we're going to replace it with a 2x4. That's it, no questions asked. It's an in-kind replacement. The other option that we have is a code compliant replacement. So that means that, yes, we would need to check stresses as they are regulated in the current building code, and the element would have to meet the current code requirements. And if that's a 2x4, if a 2x4 checks out, wonderful. If it doesn't, then we can't use it anymore. We would have to use whatever, a 4x4, a 2x6, a 4x6, whatever the case may be. And that's kind of like that paradox that we are always confronted with when there is damage to an existing structure. Do we replace in kind, or do we have to go code compliant? Let's focus for this tutorial on damage that involves elements that are part of the lateral force resisting system. All right, if you have any questions on what are the elements of a lateral force resisting system, I don't want to get into that in this tutorial. That's covered in other sessions in Bridging the Gap. So just leave us a note and we'll try to point you in the right direction. But for this tutorial, and when the damage consists of other elements that are not part of the lateral force resisting system, and you have questions on those, again, there are other sessions in Bridging the Gap that cover those as well. Okay, so with that in mind, let's jump into a little bit of an example here. We have a child care center, and it has shear walls for its lateral load resisting system. Okay, so this is a floor plan. Actually, this is the roof plan of this child care center. Here in cyan, in this area, you can see that we have highlighted a portion of shear wall that has been damaged. Now, I believe this one, yes, this one was damaged by fire. Okay, so this portion of the shear wall was damaged by fire. All right, so this is part of the lateral force resisting system. And since it is part of the lateral force resisting system, then it falls under our current purview. So, okay, how do we evaluate if this, in accordance with the California Existing Building Code, is going to trigger substantial structural damage or not? Well, we have to determine the effective length of the wall. If you're not clear on what the effective length of a shear wall is, let us know at the end of this tutorial and we'll try to point you in the right direction. But basically, you need to determine or evaluate what is the effective length of the portion of the shear wall that's damaged, and then compare that to the effective length of these shear walls that is not damaged. And I believe I am drawing a green line. This green line that I'm drawing would be the effective lengths of the walls that are not damaged. Notice how, for instance, I did not include, oops, undo that. I did not include this segment of the wall. So we're dealing with the effective lengths of the wall, not total length of the shear walls, the effective length of the shear walls. And notice how I'm also only looking in the direction that of the wall that was damaged, right? So right now, the wall that's under evaluation is this one that we're pointing to with our red arrow here. So we're only taking the effective lengths of the walls that are parallel to the damaged wall, right? So we're going to compare, we're going to do a ratio between the effective length that we've lost, that has been compromised by the fire, and compare that to the total effective length of shear walls that were in this structure in the same direction pre-event, in this case, pre-fire. Okay, so let me clear the screen and let me see if I can scroll down here. We've covered this. 10% of pre-damage capacity is our threshold. Yes, so the threshold that we are checking for is 10%. So if our effective length that has been compromised exceeds 10% of the total effective length of shear wall that we had in any given direction at any given floor, we have triggered substantial structural damage. We have to meet that higher threshold, remember, of then, okay, whatever we do to replace, it's going to have to meet the current code, as opposed to whatever we replace, because we need to replace it. It's damaged. We need to replace it. We need to replace it one way or the other. The question is, do we replace it with something that just matches what was there, or do we replace it with something that is going to meet the current requirements of the building code, the current stress checks that we have to meet for the current in the current code? All right, so the threshold is 10%. I think there's one other thing here. Yeah, was the diaphragm affected? So yeah, let's go back to this. So we've established that our wall was damaged here in this fire, right? We've established that the wall was damaged and that wall is part of a shear wall. It's a shear wall, so it's part of our vertical lateral load resisting system. Now the question is, well, was there damage to the roof as well in this area, right? Or was it? Well, let me start again. Was there damage to the roof in this area, or was it just the wall? And the answer is yes, there was damage to the roof in this area. In fact, it might have even have been broader than this. But yes, the answer is yes, there is damage to the roof. Now, why is that important? So the reason I mention that is because the California Existing Building Code is silent on how you need to repair the horizontal components of the vertical lateral load resisting system. Okay, does that make sense? If it doesn't, shoot off some questions in the comments afterwards. But hopefully it does. So if what was compromised are horizontal assemblies of the vertical lateral load resisting system, those the code doesn't cover. So there's no guidance on how you repair those. Basically up to the engineer to make that decision, whether you just want to replace in kind or whether you want to upgrade it if need be so that it complies with the current building code. But where the code is not silent is on the vertical elements that are part of the vertical lateral load resisting system. Okay, and with that, I think we're done. So again, appreciate if you give us a thumbs up if this tutorial was helpful to you. Any comments, suggestions where we can improve these tutorials, they're welcome by all means. And again, if you did find it helpful, subscribe to our channel. Take a look at our channel and you can subscribe to it. There's a way to toggle or something. I don't know, YouTube isn't my thing, so I'll leave that for others. But there's a way that you can subscribe to our channel. in such a way that if you toggle on that, then you get automatic notifications of when we upload any new structural engineering design tutorials. Okay, real good, guys.